replication is working well, or we have different usage for it. And like I said, wouldn't it be nice if we could do this automatically and make it easy? And that's replication for MySQL. The setup. The development PC, just any PC, in this case my laptop, where we're doing Windows environment, a lot of memory there for what we're really doing, but that's where we start off with. And the table created with the NoDB storage engine. Okay? Obviously online transactional, pre-default, what we want to do there. And then in a second environment, we're using the Blackhole table. Okay, we set up a replication and we change it to Blackhole. Go to what we're doing there later. What I'm not going to do today is explain how we set up replication, because that's not the objective of what we've got today. So if you want to talk about that one, or want to go into more detail on how we do replication in MySQL, we can talk about that afterwards. Or there are tutorials as well to make things a whole lot easier for you. But it's not the objective today. I didn't want to mix those things up for you. What we do in the second environment is we change it to Blackhole, and then on the third environment, we're working the production environment, is on SUSE Linux in this case, and we're obviously we want to make sure that table is working fine, storing data on the NoDB. Okay? And obviously the replication setup over here is just to make sure we understand it. Is that we have the master in our direct environment on Windows, the slave, and it's at the same time it's master in the Oracle Linux to the SUSE Linux. Okay. Now, before we move on, the fact that we have created a second environment there for the Blackhole is really relevant or is redundant. We don't really need that there if we don't want to. I mean, it's in the last two are virtual machines because I did all this in my PC, obviously. But the scenario is that using a virtual machine with very little amount of RAM is because the Blackhole is we're not storing information. We do need processing power. We do need, obviously threads and things, but to make it work fine. But we could, in fact, store this on the same Windows box if we wanted to. So keep that in mind as well. But what is the Blackhole storage engine? Taken from the documentation, accepts data, throws it away, does not store it, and any select we do on this Blackhole table, no rows selected. Okay, for those of you who don't already know that. Whenever we talk about this with customers or users, whatever, we normally say it basically sends everything to dev null. So, at the end of the day, it's doing no I/O, and that's the key here. We're not going into the operating system here. On awareness and consideration, the best thing also for the replication environment for the Blackhole is using row-based. Okay, it's best. It's not means it's the only one. However, we do use statement-based replication. We have to bear in mind certain things that may not work in that replication environment. Because we're talking about a Blackhole table, we're talking about the updates and delete triggers aren't activated. Therefore, all the auto-incremental columns that we may have that may be working in our development environment, these will not work and will break replication. Okay? So maybe we'll have to look into, is it feasible or not? Okay? First things first. But given that we've accepted that and we know we're not using that in this scenario, or for this table, because we don't have to replicate everything if we don't want to. Bear in mind, obviously, in the Blackhole environment, whatever we do there, it will be replicated onwards. Okay? So, I've got a little one there. So if replication were to break and we wanted to make a quick change in our environment, in the Blackhole environment, whatever we do there is replicated on. So if we change that to table to NoDB just temporarily because we want our replication environment to work, then the SUSE slave will be changing that way back. And if we change it back to Blackhole, what's going to happen? Obviously, the SUSE environment will say, okay, well, let's delete all these rows again. So we've just done something for nothing. So they're having impact. Also, because we're going from Windows to Linux and onto Linux, but we can Google whatever platform we want to there. Go from Windows to Linux, the best thing is to do is to use the parameter lowercase table names is equals 1, because we want to keep things standard. We don't want to mess things up because somebody put an uppercase or a lowercase. And like I say, we can configure our replication environment as we see fit. As we see fit, as in we can replicate on different levels whatever we want to. So we can do the whole database into Blackhole, every single table. We could do all but 1, all but 10, whatever databases we're looking at, or tables. Do ignore tables or do tables, or wildcards. So we can accept, if we have like a cloud solution or many schemas, many databases with the same setup, we can say with all of the ones within the one underscore percentage or asterisk or whatever, and go from there. And also just, a little word of warning there, make sure we have connectivity between environments. That's obviously a must for replication, but get rid of the firewall for a minute and let's make sure that this works. Okay, so that's the overview. Let's go into what we're doing here, how the tables are set up. So we have our Windows environment. That's all set up. All our tables are working there. So from the Oracle Linux environment, we're going to be we're dumping out all the information, confirming connectivity, making sure we're connected. Therefore, when it becomes a slave, it will work. There shouldn't be any issues there. And we're going to be dumping the database secular. And the master data equals 2 is because we're going to be creating a replication environment. So I'll tell you about the logs and auto position there. And because we'll be using GTIDs in the MySQL in this one. Because this is 560 level. Okay? And we're piping that straight through to MySQL root, so we're creating that as we're dumping it out. Show databases on the Oracle Linux to make sure we have that information back. And then we set replication up. Change master, configuration in my.cnf. In this case, to make things simpler, or because that was my need at the time, we're going to replicate only the secure database. Okay? I could have just done the crossover table. And then we check it's working. Show slave status, make sure we can see that the status of the slave updating fine, there's no lags, we're happy there. So we've got our Windows and Oracle Linux all set up. We haven't done anything that was exactly the same, all good working there. And what I do on the Windows environment here is okay, right, with my table, I haven't got any rows, so let's stick 1,000 rows in there with some procedure and make sure that we're working there. And we look at the relay bin logs on the slave, and obviously we can check the table. To make it much more simple, this is the Windows environment. We have 1,001 rows. We're going into the black hole. And you can see that in our Oracle Linux environment, that still hasn't been changed to the Blackhole storage engine yet. We've got the same rows, as expected, obviously. Oops. So we can see that the InnoDB table, where engine equals InnoDB, that's in the Oracle Linux. And then we alter it. We change it to Blackhole. Nothing more than just an alter table. But you can see there the query says, OK, 1,001 rows affected. Now, well, obviously, if we have rows in there, we change it to a black hole. As I said before, the I/O here is expected to disappear, and therefore we're not storing anything. So let's confirm that. Yep, show create table. We have our engine equals black hole, and how many rows do we have in it? None. Okay. Not that we've done any delete operations or anything like that. It's just by changing it, make sure that all the data disappears. Okay, so we've got our master slave. Master in Windows, slave in Oracle Linux. We've got our black hole table set up. It's all working well. And the replication now, okay? Bear in mind, remember what I said. Update, delete triggers are deactivated. So if we do start executing those on the master server, this will break replication. But what we're looking at here is the insert, the DDL. And should we need anything else in updating or do anything other than inserts or deletes in that sense, let's, typical scenarios, set up triggers, because we can stress not only the master environment, but stressing the black hole environment. So just because we have this one table in black hole doesn't mean that everything has to be in black hole. Depends on the resources, what we're looking at, our solution, obviously. So we connect to our SUSE Linux box now, enterprise server here, and this is our, what considered production, and we can do the same operation here, but with slight, differences. As in, we're dumping from our Oracle Linux box, 102 there. And like I said, the same, the secure and master data for a replication environment. Show databases, yep, we've got it there. We're in a SUSE box. So we set up replication again because Oracle Linux is our master. There's no problem there. We check it works with the show slave status. And now we're coming out of the black hole. So what we've just done is replicated the black hole scenario. So that doesn't make much sense if we're going to insert any data in the master, in the Windows box, by saying, yeah, okay, insert another 1,000 rows. What we're going to be doing is sending it all to Blackhole. So we changed it to InnoDB, and therefore we have all the data, the information there. But how does that work? Although, I don't know if you all know replication, MySQL, but for those of you who don't, underneath what we're doing is the bin logs are obviously, that's the replication, that's what MySQL replication relies on. So that's being transferred from the master to the slave, and in the slave where the black hole is, it's saying, okay, you want me to apply this to a table that doesn't store information, okay? I've got nothing to do here then. But what it does is the operations are executed in its own bin logs, and that's the Oracle Linux, with its bin logs, sends it to the SUSE slave. And it has its relay logs. It says, okay, so in the black hole where you didn't do anything, you just generated these logs, well, let's do it on the SUSE slave. And it repeats that and says, but now because my table is InnoDB, I can actually give you some information in the table. And what we do from to just the end, the setup on the SUSE Linux is obviously pull the information. Because we have no information, we can't insert the data again in our master Windows environment. We need to get the data rows out of the master on Windows and into our SUSE environment. Who's miffed? Who's not understanding it, or who got any questions? I want to make sure. Please. Hang on 1 second, there's a mic, Tom, so everyone can hear you.
Christos.
Hi, Christos.
Please correct me if I'm wrong. So we have the Windows master, and we replicate our data into our Blackhole storage engine, and we just produce relay logs in Blackhole storage engine.
The Blackhole also has its bin logs generated, obviously. We have logging on that one, and that's pushed onto
separate are they separate?
Yes. Yes.
So we have two relay logs?
No, we have the relay logs come from the master Windows,
yes,
and within the Blackhole environment, it generates its own bin logs.
Oh.
So, of course, all the operations that are being done on that table, they're being done, but they're just not going into any I/O. They're not being applied to the table.
Oh.
So the relay, obviously the replication would, if that's the way it works. So the data is coming from the master into the slave.
Yes.
It's being applied on a table that says, don't do anything with this. Don't save any data. So it says, okay, well, that's the way you work. What I'll do is I'll generate, because those insert commands, all that truncate, whatever, has been generated, I will also generate that in my own bin logs. So the slave itself has its own bin logs generated. And that enables us to create the SUSE slave and get that information. So that when we update from the Windows master and say insert 1,000 rows, in the middle it says, okay, you want me to insert 1,000 rows in this table? Okay, I'll insert, but then those inserts are not executed on an OS level, on a data level, but it's stored in its own bin logs. And those bin logs are transferred to the SUSE environment. It says, okay, so I'm an InnoDB table, and you want me to put 1,000 rows in this table? Okay, 1,000 rows. Select count, I've got 1,000 rows.
So we use Blackhole engine as a neutral architecture medium to try.
That's
from
right. Hold it closer.
From one to another.
That's right. That's right.
Okay.
It's like a buffer, as it were.
Okay.
It's a buffer that we can do things on, because we can use that environment with triggers, like I say, to actually store data.
Oh.
So we can audit what's happening there. But maybe the table is, gigas and gigas really big, and we don't want that information. We don't need it. What we need is the way it's been inserted, or the way it's working, or whatever our application functionality is. And we can use triggers on that to feed other tables that we want to access from this middle environment, or we want to replicate onto the other environment. So we can offload the master here that may have one use and do different things at different steps. And because on the first slave, on our Blackhole environment, where we're generating the bin logs, we can create different slaves off of that.
Oh, that's very good.
It's flexible. I mean, a good thing on this is, it can be very flexible. It has its limitations. We'll look into that right now. And there's certain things we have to bear in mind.
when using this. It's not just this simple out of the box, I'm very happy with this, but it gives us a different view of what we can do and how we can create the same table with 10 columns here and end up with a table with just 2 columns. Okay. Because we don't need those columns in production, for example. Or we want to feed off of those, or it's a NoSQL solution coming in from the production environment, and it just needs those 2 rows to make it agile. It's the capabilities there are wild.
But we're not allowed to proceed to any transformation in our data while the data are in Blackhole relay logs.
Sorry, so you're saying that if
we set up master-slave replication, Windows machine, and Blackhole environment. We transfer the data, and can we apply any insert, update statements, or create any tables in that medium?
Oh yes, I mean on the table itself is the one we will identify as the black hole using the Blackhole storage engine. Oh. So therefore, like I said at the beginning, the update and the deletes will not work. Because, of course, this table doesn't store, it has no states. So, therefore, anything that we want to change the effect of, it doesn't know the before evaluation, because when we do a select star from this table, there's nothing there. So, when we do an update on a row that doesn't exist.
Oh, okay.
Exactly. I mean, so, keep that one there. But then what we do with that is we create a trigger. So, when we insert into that table that's a black hole, the trigger updates a table that it isn't a black hole. So we could adapt it there and make different formations of that row. However, that table itself is not being updated. But I mean, for example, the typical scenario is a table that has very few inserts but lots of updates on the development side or whatever they're doing. And we want to make sure that as we go down the road, we don't suffer all that logging and all those updates that we don't really need. We want before and after. Because taking a step back, this is using MySQL Replication. So we can say that asynchronously, as in, as it happens, get the bin logs, push them across. Semi-synchronously, I want to make sure that this environment gets the information, or the time delayed. So maybe I want this to happen once a day, twice a day, because it's a reporting environment, it's a back-end environment. Like I say, it doesn't have to be development to production. We could be production to analytics or big data or whatever they want to use.
Okay, it can be run in background, as a background job.
It's not a back. I mean, for example, like I said, going back on all the way back here. Sorry, just quickly. No, it's all right.
I'm sorry.
No. On the dev PC, we can have replication set up in the same environment. Oh. Because what we want to do here is keep it minimal. Make sure that in that sense, replication doesn't really matter. What we need is that environment replicating to the second slave, the SUSE slave. So what we want is, because the black hole doesn't generate I/O, we're not using massive gigs of space. So we can have it in the same environment there, or we could have it in the production environment, obviously depending on how big or what our solution is.
All right.
Because replication there at the end of the day, works how we want it to work. And like I say, we can take a whole data, but the whole server itself, certain databases or tables, or it all depends on what we're doing.
Okay, thank you very much.
Oh, thank you for the question. If there are any more questions, any other doubts? Maybe I haven't been very graphical in explaining how replication works, and maybe my error was assuming that you all knew that one, so I do apologize there. Now, in this scenario of black hole usage replication, the whole thing is non-implosion, non-destructive. We're not going to get lots of information in here, blow up and destroy ourselves over massive uses of data or complex structures here. And also non-destructive. We're not really deleting anything. Well, it's just that the way the black hole storage engine works is obviously it just doesn't save it. But we have the information underneath in our bin logs, okay? Bin logs converting to the slaves, the relay logs. So whenever we do our truncate tables, that's all working fine. We're deleting massive loads of data. But on the black hole, we're not generating I/O because there's nothing to truncate. Bulk inserts, obviously. Got a batch load I want to test run. We can test run that on the black hole and see how the rest of the application works. Maybe it's a table that we've imported in, or the actual, the solution is pulling information from this black hole table, and I'm using triggers in that sense DDL, we can do that. We can change data types, add, delete columns, whatever we want. Finer replication capabilities, like I say, deep down, go into different alternatives. Schema maneuverability. Now, in cloud scenarios, this could be useful, making sure that we're taking just the data we want to. It's good for performance because we can take it off of the development scenario, environment in this scenario, which could be a production environment in another situation. So we're isolating different areas here. As I say, we can have it as much located on the master server if we want to, and the environments are isolated, they're modular, so it's easy to identify which ones in which area, and we know that because we created it. Now, of course, we have to be cautious about the update and delete triggers. Like I say, we don't have any information to actually create a before image. What are we going to do with that afterwards? We can't do anything. Replication will break. We're creating more tables, more different structure, so therefore the operational commitments here, the people, the DBAs behind this, and obviously people administrating underneath will say, okay, well, I have more processes, I have more need for control here. Data models, primary keys, auto-increment columns, be careful of those. Okay, make sure it's doing what we're doing. Make sure we test run this. The I/O monitoring and impact evaluation on the black hole environment is obviously removed because we have no I/O. Okay, we're not going to disk. And the infrastructure becomes interdependent because we have replication scenario. So the more layers we create, the more obviously complexity we're going to have there. So keep that in mind as well. For example, how non-implosive or non-destructive is it? This is the statistics taken from the performance schema within MySQL. 5.6, and what we've done is we've truncated the table in the master environment, in the Windows environment, and the first column here in crossover is what we started with, and with what we started with, and the difference in the white column is what we have afterwards. So we delete all the rows on the master, on Windows master. As you can see on the Oracle Linux environments, there's no change there because it's a black hole table. There's nothing for it to do. However, in the SUSE environment, we can see that the change is there as well, the difference there. The numbers, don't look at the numbers because obviously, like I say, the Windows environment was an 8 gig RAM PC, whereas the SUSE Linux was a 1 gig virtual machine. So, those are not going to be important there. But what we are looking at is obviously the changes, the fact that there are differences in the master server and on the SUSE Linux. But we're not impacting any of the I/O on the Oracle Linux box. Oh, wrong way. So keeping all of this in mind, like I said, there's an added complexity here. We're going to want to be controlling this, and knowledge is key. We need to monitor, we need to make sure we have the utilities to see what's happening, and that if it does break, or if there are any issues, or we're not quite sure of whether we're getting the information in our final environment from the original master, we need to be careful there. Okay, so what options are there? Okay, we got MySQL command line interface, obviously, the typical scenario there. Workbench utilities, I don't know if you know that, but MySQL Workbench comes with Python scripts, we call them the MySQL Workbench utilities. You can download separately, standalone, or download with, they come with Workbench that allow us to not only create an environment or clone the environment and check the differences, but also administer the replications, the slave, master, whatever we have there. So it's worth looking into. Performance schema. It's in 5.6 has been totally revamped. It's been made to help us out without impacting our production environment, our processes, so that when we do want to do our averages or our counts or our sums on the statistics of the different data that we're looking into, whether it's the statements or the stages, whatever, that's already done. There are columns called count_star, so that we don't have to. So all we do at the end is select whatever from the table where. That's already done. There's no aggregates being done there. We're not impacting the rest of the users just because we want to see how it is working. Okay? And obviously, from an enterprise edition, there's the enterprise monitor, which gives you the graphical, basically the dashboard, the console, which will allow us with the replication advisor to automatically detect our slaves, our black hole setup, and monitor that, make sure it's working, and see if there are any lags. And with a query analyzer, push that into different environments. So we can obviously tune from the master Windows box that was in development and take that into the Blackhole, see how it's working there, see what's happening, and then obviously into the SUSE Linux there. So we're fine-tuning at each of the different 3 stages there. Okay. Now, who can benefit from this? What ideas? I mean, this obviously is not the complete solution, and I would like to hear, what other ideas you may have for using the Blackhole's storage engine. But, for example, in existing inherited applications, things that we have no control over, and we want to see how they're working or how we can make them work the way we want them to. For example, using CSV-type tables in the master, and then we'd be changing them back into Blackhole and then back to CSV. So, maybe we have some simple scenarios or embedded applications there. Like I say, from Windows to Linux or vice versa, user provisioning, LDAPs, we can do different things there, make life easier. We could also, like I said, look at cloud and virtualization scenarios, different ways of using the data there, because our solution is a software as a service or internal solution where every user has his own schema as well as his own account. So they're not just one set of data there, but depending on what they're doing, and we've identified them as a heavy user, lots of data, we may want to tell them about the Blackhole staging area or user acceptance there so they can calm down a little. HA, obviously, we're talking replication. We're talking failover from master to slave. The general rule of thumb is for 10 or more slaves in a MySQL environment to use a Blackhole so that we're replicating information from that master into a slave and we can feed off there. So we can grow horizontally as well as vertically. Okay? But that's a case scenario. Also, don't forget MySQL cluster. Just because we have a standalone instance or we're going from development to production or vice versa, it doesn't mean we can't use cluster. So maybe our production environment is a cluster and we want to feed off of that into an InnoDB. But before we do that, because we're talking analytics, because we're talking different scenarios in our organization, we can take a MySQL cluster and turn it into an InnoDB, no problem there. That's just replication, that's not Blackhole. But what we may want to do is fine-tune that data we're pushing into the InnoDB and use Blackhole there. Column filtering, replication filtering, and triggers. Like I say, a lot of usage for replication and Blackhole is also deleting columns so that we don't, or we're masking or in the middle layer there, so we can adjust the table structure whilst replicating and keeping everything working. And then, of course, big data, BI, custom solutions. Like I say, if it's a heavy-duty environment on the master or in the development, we want to test that and fine-tune it, optimize it, take some time out and look at what the process is doing if it's taking too long. So we can use Blackhole in that scenario. If what I've said hasn't made much sense or you want to investigate further, or just set up replication or look at different solutions. Like I say, there's some links there, reference material, go away, play, and if there are any doubts that you would like to challenge me with, but don't want to hold a microphone or whatever, I'll be here the rest of the day, and obviously send me an email or whatever. Thank you for assisting. Thank you very much. Didn't expect me, you caught me unaware there. I was expecting a question, not a clap. But thank you very much. And also thank you to the SUSE conference. The possibility of getting MySQL here and getting you interested in hearing this is a good thing for us. We're Oracle, yes. We're MySQL as well. And you're more important than anything for us. The community, what makes us. Then we have users, then we have enterprise solutions. But I must admit, the one thing we do expect is this, is people talking about us and listening to us. So thank you very much. I mean that. And also, Evkaristo, the Thessaloniki, thank you for letting me come here. If I said it wrong, thank you. And if you're really into MySQL and you've got an idea that you want to use, go to MySQL Connect, put a call for paper. I think the call for paper now has finished, but even so, if you get a purchasing power and can get flights and everything, feel free. But if there are any questions, please feel free. No? You're not asleep because I can see people moving, so that's a good thing. But thank you very much.
Well, thank you, Keith.
Thank you very much. Thank you for the organization.
We'll have a small break, and then we'll go on with the next talk.
Thank you.
Thank you, Keith.